Today we interface with our world through electrical systems that enhances our five senses. In the age of WhatsApp, Skype, even satellites, we receive data from far away instantly.
The data is generated from the microphone and converted into digital format using data conversion schemes. Power balancing and supply problems are resolved to ensure uninterrupted power. This data can be sent everywhere, even into space and far stars, because digital data is easy to read. Logic, control, and data processing are powerful concepts for ensuring operation. But who is the controller, the logical processing? It is the chip. Arguments are converted into the language of circuits. Finally, each circuit element is critical, where electrons and photons are controlled to create, carry, and convey data. Human endeavor is served by understanding the past, solving the present issues, and imagining the future. Our community of faculty, staff, and students is committed to working on all these three aspects.
Devices and circuits form the hardware on which all ideas are implemented. The devices program at IIT Bombay is built around the IITB Nanofab, which is the most advanced academic nanoscale fabrication facility in India. The lab conducts research in device physics and engineering. We typically start with device design to account for nanoscale and quantum effects, materials growth and characterization, and then finally, nanoscale device fabrication and testing. The key focus for research and development are devices for logic and memory, neural networks, power switching and high-frequency devices, optoelectronics and MEMS, and spintronics and quantum computing. Photovoltaics is another key area. In fact, we host NCPRE, which is the National Center for Photovoltaics and Renewable Energy, the largest photovoltaics lab in India.
We live in an analog world. Our RF analog mixed signal circuits group at IIT Bombay specializes in reliable extraction and conditioning of really tiny signals with high fidelity in an extremely noisy environment, and then convert it to digital for further processing in a standard CMOS technology. We are developing RF system on a chip, SoC, for India's own GPS program called NAVIC. Our focus is on high-performance integrated circuits for optical communications, biomedical, agricultural, as well as ultra-low power sensor network applications. Our faculty is pushing the research envelope all the way from antennas to digital signal processing as well as the processors. We are on the forefront of developing technologies which will support the industry ecosystem as well as solve the India-specific issues.
Control is about analyzing and synthesizing controllers that achieve automatic control of a given system with respect to a given performance objective, like for example stability, minimum fuel consumption, etc. Increasingly, controllers are being designed using computational software packages that can simulate and design controllers based on various criteria. This has made computation central to the control problem. In Control and Computing Group, we deal with analysis and synthesis of controllers for various classes of systems with emphasis on both theory and applications. The group's research and experimental facilities include outdoor multi-UAV platforms, lighter-than-air platforms, high-performance computing facilities, autonomous driverless vehicle testing facilities, etc. The group members work in close collaboration with other engineering disciplines that include power systems, energy systems, avionics, haptics, etc. In summary, the Control and Computing Group is one of the leading research entities in control, both within this country and internationally.
The electricity sector is rapidly evolving to accommodate a high penetration of renewables, advanced communication and control technology, as well as new power electronic devices for high voltage applications as well as renewable integration. The PEPS group at Electrical Engineering is actively involved in the research and associated development. Our group has developed softwares which are being used by regulators as well as utilities. PMUs developed by us are deployed in fields. We have also developed real-time simulators for educational purposes as well as low-cost power electronic converters for rural applications. We believe that our contributions will go a long way into ensuring a smart, secure and sustainable grid for the future.
In the past few decades, we have witnessed a revolution in the field of telecommunications and networking, and our department has been contributing to this revolution in terms of academia, research, as well as policy. We have several faculty members and laboratories focusing on areas such as signal processing, fiber optics, as well as wireless communications. Many of our projects are motivated by practical issues rising due to the lack of connectivity in the country. For instance, one of our projects focuses on providing voice and data connectivity to rural areas which have traditionally been deprived of these services. As a result of this project, several villages now have access to cheap data and voice connectivity.
Electrical systems are everywhere. Every day, new solutions enable humanity to progress towards a better future. These solutions are invented by smart engineers in a creative ecosystem. Our department equips students to be such agents of change. We invite you all to be a part of this adventure.